get started. We are on page 280. All right, you got your books there? Page 280, we've been going over ratios, ratio tables, the specific one that we did today. Here's what I want to do. I want to pull up some of the answers. Let y'all check your answers. All right. And then we will move on to the next page. For sure. Here's Braden, maybe.
Is it raining at y'all's house?
Mm-hmm.
Yeah.
It is going to be a really bad storm today.
Yeah, there was supposed to be one on Sunday, but it didn't happen for me. So.
Okay, it's showing another person on here. It says demand on it.
D-man.
D-man.
D-M-A-N-D.
D-man?
D-man.
Oh, well.
Is that Braden? It's probably Braden. I feel like it's Braden.
I don't know. Where's
Let's see.
D-man.
D-man? I guess that's Braden. Where's Mr. River?
Maybe it's River. I don't know. It might be Braden. It's neither Braden or River, guys. They're the only people that would do that.
They
I thought River was Mr. River. Like,
I thought it was, no, yeah, I thought he was.
Where's Mr. River? Yeah, for some reason.
Yeah.
All right. Here we go. Here is, let me share it with y'all. Here are some answers. All right. If you haven't done this yet, you shouldn't be looking at the answers. Okay. So work on your own. Gotta get these problems in though. All right. So, oh, it was River. We didn't know who D-Man was. It was you.
D-man. River, why did you change your name?
D-man.
River, did you finish your homework? River, can you hear me?
I don't think he started his thing yet. Did he start his audio yet? Oh, there he goes. It was on mute. Maybe it's on mute. No, he wasn't even talking. I didn't see it.
All right, give me a thumbs up when you're done.
Almost. Okay.
Okay. How many of you got number 12 correct?
Me.
Your number 12 correct? Phoenix, how'd you do on that one?
Oh,
Yes, remember when we're going from miles bigger to smaller, we multiply. When we're going from smaller feet to bigger, we divide. Y'all remember that? All right. So here we go. Any questions on page 280? Something where you're like, I do not get that. Because these ratios are they're a little tricky to find the unit rate and getting all your terms down. But any questions over that one? All right, we are moving on to page 281, and I'm going to do some of the problems with you guys. All right. Here we go. We're making ratio tables to solve problems. So here we go. Let's just start with number 21, 22, and 23. Everybody got their books open? Got a piece of paper to do your work on? Here we go. Number 21. The directions at the top say use the ratio table to answer the question. So they actually give us a ratio table over here to the side, right? They tell us, let's see, this is students to admission. So if there are 3 students, admission's going to be $19.50. 5 students, it's going to be $32.50. 6 is going to be $39, and 12 will be $78. Okay. Let me just ask you this, Blake. What's the pattern here? How would you find the pattern to know? Well, how do you know? What if there were 8 students? How much money would 8 students be? How do we find the pattern here?
You have to see how the same they go on the way.
So what operation would we do to find it? Anybody? How do we get from $32.50? How did we get that out of knowing that it was for 5 students? Or how did we get $39 for 6 students?
Because they add every time.
Not adding, we're multiplying. So therefore, we would need to divide however much money they're paying for admission, divide it by how many students, and we should find a common number. All right. So here we go. Let's go to number 21. A group of students is visiting the History Museum. The table shows the price of admission that different groups will pay. All right. Here we go. How much will a group of 20 students pay? So we've got all this information right there. What is one thing that we don't know right now?
How much one student pays?
Very good, Nora. And what do we call that, Parker? We're trying to find it for one person.
So we have to find the cost of what it is for one person,
which is the unit rate. Okay. So Blake, tell me what's my ratio? First and foremost, my ratio is what?
3 to 19.
Okay, that's my initial ratio. 3 students is to admission of $19.50. So I want to know, what about 1 student? How much money would 1 student be? Well, how did I go from 3 to 1?
Divide it by itself.
Divided by
3.
So how much money would 1 student be? I have to divide that by 3. 19 divided by 3, what is that, River? 19 divided by 3.
4. No, 6.
6. My remainder is 1. Parker, 15 divided by 3.
5.
Don't forget that decimal right there. And I've got 0 as a remainder. So therefore, my unit rate is going to be $6.50 per student. So how much is 1 student? $6.50. Now, if 1 student is $6.50, how much would it be for 20 students? How would you find that? Well, going from 1 student to 20 students, that was we multiplied the top by 20. Therefore, we got to multiply the bottom by 20. So $6.50 times 20. You've got a 0 on the end there. You can hang that off, come back to it later. Now tag on the 0 there. So how much is it for 20 students?
$180.
Okay, I don't see everybody writing this down. Okay, you're supposed to be doing these problems with me, all right, on your own paper. So that was a lot of work for just number 21. We had to find, first off, what was the rate, the unit rate? The unit rate is, well, each student costs $6.50 to go into the History Museum. Well, if we've got 20 students, then it's going to be $130 to get in. Number 22. All right, I'm going to keep my chart there. I'm going to keep my unit rate there. Read number 22, Phoenix.
How much will a group of 24 students pay?
Okay, how would we find 24 students? Well, again, here's my ratio. Can I write my ratio either way? Sure. I could put $6.50 per one student. So therefore, how much would 24 students pay? River, how did I go from 1 to 24?
Multiplied by 24.
So Blake, what do I have to do to the top?
Multiply it, then divide it by 20.
Ooh, so if I multiply down here, then I have to divide up here.
Not multiply up there.
All right, Blake, tell me, what do you get? What is $6.50 times 24? Do it on your paper and tell me what your answer is. Parker, I want you to do number 23 and tell me what you get for your answer there.
Yes, ma'am.
River, did you get an answer for number 22?
No, not yet.
All right, keep working.
I have it.
What'd you get?
15,600.
Check your decimals. Did you put your decimals in?
Not. Oh, no.
So what'd you get? Because you're close.
$156.
There you go. Very good. So the ratio here is $156 for 24 students. Parker, what'd you get for 23?
$227.50.
I think you did your math wrong. It should be $175.50. Did you multiply $6.50 times 27?
I multiplied $32.50 times 7.
Ooh, not $32.50. You got to get your initial unit rate there. So $6.50 would be your initial unit rate. All right, let's move on. Let's let's look at 24, 25, and 26. All right, Rachel's gas tank can hold 15 gallons. Her car can travel 420 miles on 1 tank of gas. So here's my chart over here, my ratio table. We've got gallons and miles. So 15. 672, and 30, and 840. All right. Number 24 says, how far can the car travel on 40 gallons? So 40 gallons will go how many miles? Well, what am I missing right now?
The ratio.
My unit rate. How many, before I can even answer this, I've got to come over here and I've got to say, all right, well, if she can go 420 miles over 15 gallons, I want to know how many miles can I go in 1 gallon? How would I figure that out? Well, again, this is my unit rate, okay? A value over 1. This right here tells me I can go 15 gallons, 420 miles. So, I went from 15 to 1. I had to divide by 15. So therefore, in order to get my original unit rate, I have to divide 420 miles by 15. So what is 420 divided by 15? Nora, give me your answer. Everybody else working on your own. So I should see you writing right now on your papers. $42 divided by 15 is what, Nora?
2.
Good. 42 minus 30 is?
12.
Mm-hmm. Bring down your 0. 120 divided by 15. Blake, did you finish that?
Yes, no, ma'am.
All right, keep working. Work with us. 120 divided by 15, what'd you get for that one? Figure it out, Nora?
Almost. 8.
Yes, very good. 8 times 5 is 40. 8 times 1 plus 4 is 12. Remainder of 0. Okay, what was this 28? What does that tell us?
What? 28.
28 was 420 divided by 15. So that means she can go 28 miles every 1 gallon. So this is my unit rate. How many miles can she go in 1 gallon? 28. So how many can she go in how many miles can she go in 15 gallons? 420. And so on and so forth. You got your ratio table. Okay, let's go back to our original question, number 1. Or excuse me, not number 1. Number 24. So here's our unit rate. She can go 28 miles per gallon. Remember that slash means per. I want to know how many miles can I go in 40 gallons then? Well, here's my, let's see here. Start out with your unit rate. So 28 miles for every 1 gallon of gas. Well, if she were to put in her car 40 gallons of gas, how many miles would she go? Blake, what you got? What do I have to do to find this?
You have to multiply.
Multiply top and bottom by 40. So, Phoenix, 28 times 40. Do this one with me. 4 times 8.
32.
4 times 2 plus 3.
11.
And then tag on your 0 here at the end. So 40 gallons of gas would allow her to travel 1,120 miles. Parker, is that what you got?
Yes, ma'am.
Awesome. Very nice. Do number 26. Everybody, go. Give me a thumbs up when you found the answer. Parker, try number 25. All right. Phoenix, what did you get?
Got 112 miles.
That is correct. Yes. You had to use your unit rate. There's 28 miles. She can go 28 miles for 1 gallon. So how many miles can she go in 4 gallons? Well, how to multiply top and bottom by 4. That is 112 miles. Very good. All right. And then lastly, let's look at number 27. There's less gravity on the moon than on the earth. A person who weighs 120 pounds on the earth would weigh about 20 pounds on the moon. Huh. So if you're ever thinking about losing weight someday, go to the moon.
Yeah.
But if you don't, boys, y'all want to, some of y'all, I talked to Boogie the other day, and Boogie's trying to eat so much food right now because he's trying to gain weight. And I'm like,
Why is he trying to gain weight?
goodness. So if you're trying to gain weight, don't go to the moon because you'll be
trying to lose.
discouraged, right? So 120 pounds on the earth would be the equivalent of weighing up 20 pounds on the moon. Huh, okay. So number 27 says, about how much would a 200-pound person weigh on the moon then? Well, now I can use this as my unit rate, but I do like to get it down to, okay, well, 120 pounds on the earth versus 20 pounds on the moon. Well, let's see here. So technically I could use this as my unit rate too, or I could use this as my ratio. How much would someone weigh? Let's see, if someone weighed 200 pounds. Nah, let's get our unit rate. So I want to know 1 pound. If someone weighed 1 pound on the moon, how much would that be equivalent to on the earth? Well, gotta divide top and bottom by 20. So what's 120 divided by 20? That's 6, right? So here's my unit. Here's my unit rate right here. If you weigh 6 pounds on the earth, so if you take a baby up to the moon, he's only gonna weigh 1 pound on the moon. So here's my unit rate. Now I want to know if someone weighs 200 pounds on the earth, how much are they going to weigh on the moon? Well, what did I do? I multiplied 6 times what to get 200?
20, I mean.
You can come over here and divide it. 200 divided by 6. Huh. It's going to be a weird answer, isn't it? What did you multiply 6 by in order to get 200?
Uh,
Huh? What did you multiply 6 by to get 200? Well, what's 200 divided by 6? River?
33.
Yes,
And a
about
third.
33 and a third. Therefore, about how much would somebody weigh on the moon if they weighed 200 pounds on the earth? About 33 or 34 pounds. Interesting, interesting.
Huh.
And it is true that if you were to go to the moon, you would weigh less than what you would weigh here on the earth.
you'd be able to jump a lot higher.
All right, turn to page 282. Here we go. I'm going to do some of your homework with you. So for homework tonight, you are doing page 282, numbers 1 through 16, all. All right.
Mhm.
And I will do some with you right now. Sound like a plan?
Yes, ma'am.
Then let's roll. All right. These are proportions now. Okay. Well, first off, what is a proportion? Well, proportion are two ratios that are equal to one another. So remember, here's a ratio, 2/4, correct? That's a ratio written in fraction form. And a proportion would be a ratio that is equivalent to another ratio. Are these two ratios equivalent? Is 2/4 equivalent to 4/8?
Yes.
Yeah.
So this is called a proportion. Two ratios that are equivalent to one another. How can I check to see if there's a couple different ways that I can check to make sure that they are equivalent proportions. Well, I could reduce them down. 2/4 reduces to 1/2. 4/8 reduces to 1/2. Yep, those are equal. I could also cross multiply. 2 times 8, is that equivalent to 4 times 4? Well, 16 is equal to 16. Yep, those are equivalent proportions. I can make 2/4 a decimal. 2/4 as a decimal is 0.5. 4/8 as a decimal is 0.5 as well. Yep, those are equivalent proportions. So let's do an example. Let's do number 1. All right, again, I need to see all numbers 1 through 16. So you better do them with me right now if you want these to count. You don't have to go back and redo these. The instructions say to write the ratio in lowest terms to compare them. Okay, so here are my two fractions. 12/14 and 36/42. So I need to reduce these fractions in order to compare. Are they equal to one another? Or are they not equal to one another? So Blake, do the first one for me. 12/14. Reduce that down. What's the greatest common factor between 12 and 14 that I can divide out?
2.
Okay, what's 12 divided by 2?
6.
And what's 14 divided by 2?
7.
Okay, 6/7. I can't reduce that anymore. What about 36 and 42, Grace? What's the greatest common factor between those two numbers?
6.
Okay, let's divide out a 6 then. From top and bottom. What's 36 divided by 6?
6.
And 42 divided by 6?
7.
All right. Are these two fractions equal? Yes, they are. All right, let's do number 4. So again, we are reducing the fractions down to the lowest terms, and then we're comparing them. So River, Reduce 9 over 15. What's the greatest common factor in 9 and 15? What can we divide out?
3.
There we go. So 9 divided by 3, that is 3. 15 divided by 3 is 5, so 3/5 is what I can reduce it down to. What about 6 and 10, Nora? What's my greatest common factor?
2.
There we go. 6 divided by 2,
3.
and 10 divided by 2 is 5. Number 4, those are equivalent fractions as well. All right, so you'll be doing numbers 2 and 3 on your own. Here we go. Let's move to number 5. Write the operation that was performed on both terms. So here we go. We've got 9 over 14 is equivalent to 27 over 42. How did I go from 9 to 27 and from 14 to 42? What was done to top and bottom, Parker?
They were multiplied.
We multiplied by 3 on top and we multiplied by 3 on the bottom. That's the answer. What about number 7? Phoenix, you help me with this one. 9 over 11. So these are equivalent fractions. 9 over 11 and 81 over 99. How did we go from numerator to numerator and denominator to denominator? What did we do?
You multiplied it by 9.
Multiplied it by 9, top and bottom. What is 9 divided by 9? And what's 3 divided by 3, River?
1 over 1.
When we multiply something by a value of 1, 4 times 1, 5 times 1. Anytime we multiply something by 1, it's going to be itself. So just because we're multiplying it by fractions, it's still going to be equivalent to itself when you reduce it back down to lowest terms. All right, let's do number 11. Now we're going to use cross multiplication to prove that these ratios are proportions. So 30 over 12 is equal to 20 over 8. All right, let's check to make sure that these are equivalent proportions. So we have to cross multiply. So 30 times 8, is that equal to 12 times 20? Let's do our work over here to the side. 30 times 8, that's 240. And 12 times 20, that is also 240. Do I need to show this work, Parker? Do I need to show all that work?
Yes.
Oh, yes, I do. Because the instructions tell me prove that this is correct up here. Prove that you can use cross multiplication to show that these are equivalent proportions. So do I need to show me actually cross multiplying and finding the answer of 240 on both sides? Yes, that is very important. All right, let's do number 13. Last one, use division to find whether the ratios are proportional. Write decimal comparison using equals or not equals. Okay, so I've got 2 over 4, and I want to know, is that equal to 15 over 30? Well, first thing I want to do is just reduce it down to lowest terms. So 2/4, that's 1/2. 15 over 30, that's 1/2 as well. But it says write them as decimals. So is 0.5 equivalent to 0.5? Yes, they are. They are equivalent to one another. And if they're not equivalent to one another, then you would say they are not equal to. All right, well, I did a few of the problems with you. Again, I'm going to put it on Google Classroom, numbers 1 through 16, all for page 282. Those of you who did not turn in today's assignment or yesterday's assignment, that needs to get done, okay? Tonight, you don't have a very big assignment at all, so use today to catch up. and post those pictures on the assignment. Phoenix, run upstairs right now, grab that phone, take a picture of your test, okay, those problems that you're missing, and send that to me right away. Anybody got any other questions or comments? Yes, reach out to Braden, make sure he's doing well.
we've been texting him.
Better. All right, so, all
He's fine.
right, kiddos, we'll see you tomorrow.
Yeah, he's
Friday.
on his PlayStation, but
Do what?
so he's sometimes playing, and we talk to him.
Yeah. Well, he needs to get better so he can come on Zoom with us. See you.
Yeah.
All right. Miss you guys. Hope you're doing well. I'll talk to
Bye.
you later. Bye.